Well, I don't think I've mentioned that yet, that I used to teach 7th grade. And so when I start this section of factoring, I actually start by doing some factoring with pictures. Okay, so notice if I had something like this, square times y plus square times x plus square times 8. When I factor, right, what I'm really doing is I'm looking at what's common to each and I'm bringing that outside. And keep in mind I'm dividing it out, right? Because this means square times y. So if I divide this term by square, right, I'm left with just y, right? And I'd be left with just x. Oops, that's a little off there. And then I'm left with 8 here. And I have to be able to multiply back in and get where I started. Okay, so we have to get used to, I used a little square here, but here I'm using a large rectangle because sometimes I can factor out something large, right? And so if I factor out large rectangle, I am left with, well, let's see, right here I'm left with x minus 1. I could keep it in parentheses, or I actually don't have to. And then here I'm left with x squared. So see, within the outer parentheses, I could drop this inner set of parentheses, right? And write this into standard form if I wanted. Because what we'll get to later is we're going to have something in parentheses like x minus 2, right? Like a binomial. Okay, and I can factor that binomial out. Okay, so what I would be doing here, factor out the binomial x minus 2, and then be left with this in parentheses, so that my final answer would be, and I don't have any like terms in this set of parentheses, and it's typically common to arrange this into standard form. And then I look and see if I could factor this further. Factors of 1 are just 1 and 1, and I would need 1 positive and 1 negative, and so I'm not going to be able to break this trinomial down into 2 binomials. So this would be my final answer. So anyway, back up to the exercises on the page. All right, I take a look here in number 3. Okay, and I say, well, what could I factor out of each term? A term is anything between a plus or a minus sign. Okay, so this is a term, and this is another term. Okay, so what's a common factor? And I can see x squared minus 1 is my common factor. Okay, so that would get factored out. Okay, and then what's left? And what's left is x squared minus 9. And then actually that can be factored further. Okay, so this could be factored further to get me to, because those are difference of 2 perfect squares, x minus 1 times x plus 1 times x minus 3 times x plus 3. I know when you see an expression like I started with in letter A, your first thought is probably to distribute, okay? But notice if you had tried that with distributing and then tried to factor, you would end up with a horrible mess, okay? So this idea of factoring by grouping works much better than trying to distribute. So come over to letter B, pause the video, and give letter B a try. So again, look for what is common to both terms. A term is anything between a plus sign or a minus sign. So this expression has 2 terms in it. This is the first term here. This is the second term here. All right, so pause the video and give this a try. Okay, so if you just came back to check your work, if I factor out, so there's two factors I can take out, right? X minus 1 and an x plus 2. If I do that, I am left with one factor of x plus 2 here. And I'm going to put it in parentheses for the moment. And over here, I would be left with one factor of x minus 1. And sometimes students will say to me, how come you're using those brackets, right? Why don't I just have normal parentheses? These brackets mean the exact same thing as a normal pair of parentheses. So I'm using this to kind of separate and like break my problem up into different chunks. So I decided to use brackets here to distinguish that that's what's left over after I've taken these factors out. So now I can clean this up a little bit, what I have in parentheses. I better remember to distribute my negative, right? And so when I do that, I'd have x plus 2, distribute the negative, that becomes plus 1. And so ultimately I am left with, the x's are gone, those would zero out. I'm left with a 3. And so normally we put our 3, our coefficients, out in the front. Okay, so in simplest terms, I would be left here. Okay, as my final, simplified, fully factored answer would be right there. So moving on to C, and C looks horrifying, right? Everyone's going to look at C and just, be overwhelmed and not know what to do here in letter C. So one of the things that we have to remember is when we're factoring, let's look at something really easy. If I'm factoring this really easy thing and I take out a 2, right? How do I figure out what goes in parentheses, right? And all of you know the answer to this, but stop and think what you're doing. To figure out what's left, you're dividing each term by 2, right? To get the x minus 4. So we're going to apply the exact same idea here. Okay, so we get x, actually bear with me a second here. I'm going to bring this way down to the bottom. So 3x to the negative 1/2. That's what's getting factored out, and I need to know what's left. So what I'm doing is I'm taking every term and I'm dividing it by 3x to the negative 1/2. Okay, so every single term gets divided by this. And yikes, I can't quite write this small enough here. The last one's going to be easy, right? Because what's going to happen to the last one? When I divide this, right, the x's and the powers will cancel. I'll just get a 2. Okay. But how do we divide exponents, right? Like say let's look at a simpler example again. So say I have x to the 8th divided by x to the 5th. What am I doing to the exponents? Okay, and we should know the rule that says, oh, if you divide powers of the same base, you subtract the exponents, right? This would result in x to the 3rd. Okay, so I follow that same rule here. So let's see, we'll do the easy part first. The 3's are gone, right? Now I have to subtract the exponents. Okay, so what is 3/2 minus 1/2? Why am I having trouble writing? Maybe it just doesn't like that I'm up at the top. I'm like struggling to write here, sorry. Minus, right? Which we know minus becomes plus plus. And that would give me 4/2 when I add. 4/2 is 2. Okay, so I would get x squared. Again, check your work by distributing back in. Okay, if I distribute it back in, now the rule is add the exponents. Okay, well, what's 2 if I have 2 whole dollars and then I take away a half? a dollar. I have $1.50, right? Or $1.50, which is 3/2. All right, so it checks out. So you decide what happens here. All right, take a minute and try that. Okay, but look what I'm left with. A half minus minus a half, right? Becomes a half plus a half, which is 1/2, right? So that's x to the first. So as ugly as that looked, after I factored out the x to the negative 1/2, I get a nice looking um, trinomial left. And actually, does that factor further? Can I go like this? And I certainly can, right? If I wanted to factor this fully, right? I can do that. Factors of 2 that give me 3. And if you would rather, some of you are saying, okay, don't you like things written with positive exponents? Sure, right? Maybe I'll bring that downstairs and write my final answer like that. And doesn't that look a lot nicer than what we started with? Okay, so that's why we might do something like that.